So now we're going to install what's called an IDE or Integrated Development Environment, which will allow us to write C programs and run them on our computer. So just search for code blocks, and I want you to go to this website. Over here we're going to downloads, and in here choose your operating system. I'm using Windows, and we have to download the setup that contains MingW. We must have MingW in order to be able to run our programs. So now we click on one of these links. I'm going for this one. So this website will open and we have to wait. And now the download should start. I already downloaded code blocks, so after you do that, just go to the download and now double click on it. And now just proceed with the installation. So next, I agree, next, and install. I already installed code blocks, and after you do that, you'll find a shortcut on the desktop for code blocks. If you double click on it, code blocks is going to open. So in order to start, we have to create a new project. So we press here or we go to File, New Project. Right here we choose Console Application, we press Go, and we choose the C language, then Next. And now we have to name our project. So I'm going to call it section 1.1, and here we will choose where we're going to save our projects. So I'm going to put them in a new folder on my desktop called C. And now we press next, and because we downloaded MingW, all this should be filled by default. And now we press finish. And now our C project is all set up, and if we press here, then here, this code will appear. This is a C program that prints hello world. So let's build and run it. I'm going to press here, and we're going to see this output. When we made the project, we chose console application, and in this case, this is our console. So now that we're sure everything is working correctly, we're ready to start learning C. So in this video, I want to talk about this code. So over here, I'm using the number sign followed by include. So this means that I want to use something inside this file, alright? So I want to include, and in angle brackets, I'm saying standard input output and standard library .h and .h. This .h means that these files are header files, and a header file is basically a file that contains some C code that is already written and we can use it. Alright? So for example, this printf, we know that it prints hello world on screen, but I don't care about this right now. What's important is that if we right click on it and press find declaration of printf, you will see that standard input output.h automatically opens, and here we have the declaration of printf. So in order to be able to use printf in this file, I'm including the standard input output header file over here. So then I'm going to use something from inside this file over here. For example, printf. Alright? So to keep things simple, you will include these two files every time in your program because you will always use them. Now, this over here is called a function. Let me tell you about the parts of the function. First of all, it has a type. So the type of this function is an integer, and we type it int. So an integer is a number without a decimal point. So for example, 0, 1, -2, -3, okay? Any number without a decimal point. Then we put a space and the name of the function. So the name of this function is main. And this is a special name because this function is the main function inside any C program. Then we put some parentheses, we will talk about them later, and then we have braces. And inside the braces, we have the code of the function. Basically, a function is a group of code, alright? So, this main function has two sentences, right? This sentence ends with a semicolon, and this sentence ends with a semicolon. So whenever you see something that ends with a semicolon, it is called a statement or an instruction. And it's basically a sentence that makes some action. So for example, printf prints something, right? So this is an action. Now return 0, let's talk about it. I'm going to press over here, build and run. So this basically will transform this code into a program that my computer can run, and it will automatically run it. So press on it, and here you go. This is the result of printf, it printed something, and this over here is the result of return 0. So the process returns 0, so the program returns 0, alright? So let me close this, and change this to be 1, for example. Now build and run again and have a look. Now we have process returned 1. Alright? So since the type of main is an integer, we can tell it to give us or return an integer, and that is using the return, and after it we put the integer that we want, and usually we put return 0 to indicate that when we run our program and it finishes, everything works perfectly without errors. So let me build and run. So now we see process returned 0. This indicates that our program ran successfully and it has no errors. Now if we have an error, we will see something different than return 0. We may see a long negative number, okay? I don't know. But what's important is that whenever we see process returned 0, we will know that our program ran successfully without errors. But let me tell you something. Sometimes we see return 0, and even if we see it, we still have some problems in our program, but don't worry, we will talk about that later. What I want you to know right now is whenever we see return 0, we can suppose that everything is okay. Alright? And later on, we will see the importance of this return statement or instruction whenever we start making functions of our own. Alright? Now, one more thing to say about the main function. As I said, it is the main function in a C program. So, whenever I build and run the program, this will create a program and run it, right? So, when I run the program, the first thing I do, I come to this function and start executing the instructions inside it. So later on, when we make functions of our own, we will use these functions from inside the main function. Okay? And don't worry, everything will be clear. But now just have the idea. Now, one more thing to talk about. Suppose you want to say something about the program. So for example, this program prints something on screen. Okay? So let's try to build and run the program, and we have an error. And this is basically because we are typing something that C does not understand. This is a human language and this is not a C code. So this will cause an error. So to be able to write something in a human language, we have to make it a comment. So it is not considered a part of the code. So we put 2 forward slashes, and to make it a little bit bold in code blocks, we put 3 forward slashes. Now this over here is a comment and it will be ignored. It's not a part of the code. So build and run, and now the program works. Okay? So this is a single line comment. So if we type something over here, it is not a comment. So to make a multi-line comment, put forward slash star star forward slash. So whatever we put over here will be a comment. So have a look. Everything is in gray. So everything is a comment. And to make it a little bit bold, put more stars over here. So now if I build and run the program works and these are ignored. Alright? So this is it about comments. So whenever you want to write something and explain and put some details, use comments. So here is the code from the previous video, and I will remove these comments. Alright? I don't want them. Now I want to talk about the build process. So we have a C code over here, right? When we press build and run, a program is created and we run it on our computer. Okay? So this code is written in the C programming language. So to be able to run it on our computer, we must convert this code into a program that the computer can understand, so we can run it on the computer. So you remember the compiler that I told you about? This compiler is responsible for transforming this code from the C language to a language that the computer can understand. Okay? So let me show you this. This is my project folder. Over here I have a folder called OBJ. This is short for object. Open it and open this, and over here you will see main.o. So the main.c file contains our code in the C programming language. Then the compiler converts this to something that the computer can understand, and this thing is this file over here. This is an object file. It contains a code that the computer understands. Alright? So this is the job of the compiler. It compiles the code from a high language, which is in this case the C programming language, to a low language which the computer understands. So the high language a human can understand, and the low language the computer can understand. Okay? Now this object file, double click on it, and as you can see, I cannot run it on the computer. It's not an application. So the compiler does not make an application. Let me go back over here, open this bin. It is short for binary. Open it, and this, and over here I have an application. So this is the program that can actually run on my computer. Let me tell you what happens. First of all, the compiler transforms the C code into object files. Okay? Then something called a linker links the object files with other files that we are using in our program. For example, we saw these header files previously, right? We are using them inside the main.c file. So the linker combines the object file that the compiler created, which is the main.o file, with the header files that we are using. And when everything is linked together, we get this application. And this is the program that can run on the computer. Now let me show you this. Double click on this, and as you can see, it is opening and closing very fast. So let me tell you why. In code blocks, if we try to build and run this, it runs and it stays over here, right? And this is because we are running it inside code blocks. So over here, I'm going to add something, system, and put double quotes, and inside put pause. So now I'm going to build a new program and run it. So build and run. And now as you can see, we have this press any key to continue. So press anything, and now the program ends. So now I have a new program that pauses before it exits. So now if you try to run it, this is the new program. Double click and have a look. It runs and then it waits for me to end it. So now if I press something, it will close. Alright? So later on, I might not use system pause because I'll be running the program from inside code blocks. But if you want to run your programs from over here, you should add this system pause. Okay? So the build process is 2 steps. First, the compiler works and then the linker. Okay? So have a look at this button. It builds our program and then runs it. But this button only builds the program. So this executable file will be created. Then this button runs the executable file. So for example, if I make some changes over here and I don't build the program, let's try to run it. Over here we see the current program working. Okay, we did not create a new program. So let's create a new program. So build, and now this file over here changed. So if I run it over here, we can see the new program working. And this button over here builds and runs the program in the same time. Alright, so this is all about the build process. I know it's boring, but it's important to know what happens whenever we create programs. So let's say that I have some information and I want to store this information. Okay, we all know that our computer has something called memory or RAM. Okay, when we run our program, it is loaded into the RAM and it works over there. So if we want to store some information for our program, we can store it in the memory. So in order to store anything, we need a place in the memory to store data in. So this place is called a variable. To make a variable in the memory, I'm going to put a comment over here. First of all, we specify the type. So if I want to store a number, I should choose a type for a number, for example, integer. After the type, I leave a space and then I put the name of this variable. So imagine you have a box and you put a label on the box, okay? So this name is a label. So I'm going to call this num, for example. And now I just put a semicolon. So right now I have a box called num, and let's say it is of type int. So this box stores integers, and this is basically a variable, okay? This is a declaration of the variable. So I made a box in the memory to store an integer in. This is declaration. Now we're going to dive in. Let me remove this because I forgot it. Okay. So over here we have int i1. So now I have a variable i1. This code over here, I want you to ignore it. I'm just printing the value of i1. So all these printfs for this video, pretend that they are not here, okay? I'm going to run our program in order to see the values of the variables. So first of all, we declared i1 and I printed its value. And as you can see, there is 74 inside i1. This is an interesting thing because we didn't put anything inside i1 and it already contains a number. So keep that in mind. Now let's say I want to put a number inside i1. So simply I'll say that i1 is equal to 5. This is called the assignment operator. it takes the value on the right and it puts it in the variable on the left. So now this 74 is going to be erased and 5 will replace it. So I printed I1 and as you can see we have 5. Okay, now I do another assignment. So I1 is equal to -3. So we say goodbye for 5 and when I printed I1 we get -3. Okay, so as we said, I1 stores integers, so numbers without decimal points. Over here I'm trying to put 3.5 inside I1. Okay, I printed I1 and as you can see there is 3. So this 0.5 is lost. What's happening exactly? This is casting. 3.5 is converted to an integer, so the decimal point and all the numbers after the decimal point are lost. So we get 3. So as you can see, this type of casting happened automatically. Later on we're going to do casting manually. Perfect. Now I want to show you something. I have this line of code commented, so if I want to remove the comment I press Ctrl+Shift+X and I get rid of the comment. So what I'm saying here, int I1 is equal to 2. Okay, let me try to build the program. So I want to transform this code into a program that the computer can run. Okay, just build. You'll see that I get an error, and this error is because we already declared I1 and over here we are declaring it again. So this is a problem. Regarding this equal to, just pretend it's not there. Okay, just like this. Let's try to build and we also have the same error. So I'm going to comment this line of code, press Ctrl+Shift+C and it is commented, and now let's build and the error is gone. So let me run this again. As I said, we have 74 over here. This is garbage, so it's always better to initialize our variables. So what's initialization? Initialization is giving our variables some value when we declare them. So over here, let me say int I1 is equal to 0. So this is initialization. And now I'm pretty sure that I1 contains 0 and nothing else. So it's a good thing to always initialize variables. Okay, so this now is called initialization. Okay, now we want to store a variable with a decimal point. So we're going to use a type called double, and we also have another type called float which does the same thing, but double has more precision than float, so always use doubles. So the same thing, I'm declaring a variable called d1 of type double and I'm initializing it to be equal to 3.5 and I'm printing it, and as you can see d1 is equal to 3.5 and it automatically prints 6 digits after the decimal point. Okay, now if I say that d1 is equal to 0, 0 will be casted or converted to a double, which is 0.0 in this case, and we have it over here. And this over here is an example for a float called f1, so I initialize it to be equal to 3.7 and I printed it and it is over here. Perfect. Now let's suppose we want to store a character. Look at your keyboard, the letters you see. Suppose you want to store any of them inside a variable. We have a type called char, it is short for character. So I'm making a character called C and I'm initializing it to be equal to A. A very important note over here that A is put inside single quotes, as you can see. I didn't put A in double quotes. A in double quotes is a string, and that is a group of characters or a text. We'll see an example in a little bit. But the point here is to always use single quotes with characters. This is very important. So let me build and run this, and I'm printing this character and we see A. So now if you can pause the video and go take a look at the ASCII table. Google ASCII table and you'll see a table of characters and numbers. I want you to look for the letter A, big A. You will see that the decimal number of this A is 65. So look what we're doing right now. We're saying that C is equal to 65. So because C is a character, 65 is going to be converted to a character. Just like when we had an integer and we converted it to a double, and when we had a double and we converted it to an integer. It's the same idea. So this 65 will be converted to a character, and in this case, this character is A, according to the ASCII table. So I printed C, and as you can see we have A. And now I made an integer called code, and I set it equal to the character A. The same thing will happen. A as a character will be casted to an integer, and according to the ASCII table, when I printed code, as you can see we have 65. Now we're going to talk about booleans. A boolean represents true and false. True is always represented by 1, number 1, and false is always represented by 0. So here is the type underscore big B OOL. So I'm making a boolean variable called B, and I set it to be equal to 0. 0 means false, okay? So I printed B and I see 0 perfectly. Now I set B to be equal to 1 and printed it, and we see 1. Now's the interesting thing. I set B to be equal to 2 and I printed it, and I also see 1. And also I set B to be equal to -1 and printed it, and also I see 1. So what I want you to take from this, 0 is the only thing that gives me false, and everything else is true. So all of these are ones, and only 0 gives me 0. Now we can use some keywords such as true and false, and in order to do so we have to include stdbool.h. As you can see, I already included it over here. So I'm setting B to be equal to false and I'm printing it, and we have B is equal to 0. Then I'm saying B is equal to true, then I printed it, and we have B is equal to 1. Perfect. Now we're going to see a string or a text or a group of characters. You don't have to fully understand it, I just want to give you an overview, okay? So a string is a group of characters. So as before, we have this type characters, and I'm calling it name. And these brackets, I'm saying that I want a group of characters. And in this group of characters, I want to store this group of characters. I put it in double quotes. So since I put this in double quotes, C understands that this is a string and it knows how to deal with it. So now when I print this name, as you can see, we have this text or string or group of characters printed perfectly. These are the main types, and we're going to see more types as we go through the course. For now, this is pretty much enough. I want to show you an example of how we can know how much a variable can hold. You don't have to memorize it, you can always Google how much can I store inside an integer or inside a double, but it's a good thing to know. So again, I don't need you to understand any of this, I'm just giving you an idea. First of all, I'm getting the number of bytes of an integer and I'm storing it inside x. Then I'm printing x. So the number of bytes of an integer is 4 bytes. So whenever we want to make a variable of type integer, we are saying that we want 4 bytes inside the memory for this integer. Now we have to calculate the number of bits. 1 byte is 8 bits. So 4 bytes equals 4 times 8 bits, which is 32 bits. And now, to know how much we can store inside an integer, we just calculate 2 power 32. So 2 power 32 is this number over here. So we can store this much inside an integer. Note that this number is divided between the positive numbers and the negative numbers. And I'm also going to put a link in this lecture resources, and you will see a table containing the data types and how much can we store in each data type, and many more details if you're interested. But for me, this is pretty enough right now. So let's have a look over here. I have an integer x initialized to be equal to 10 and double y initialized to be equal to 3.0. I'm assigning x to be equal to y. So what's going to happen over here? We're going to calculate the right side, which is in this case y, and y is equal to 3. Then we're going to store this 3 in x. So 3.0 will be casted to be equal to 3, then we put it inside x because x is an integer. I'm going to build and run the program, and I printed x and y, and as we can see, x is equal to 3 and y is equal to 3.0. Okay, so what if I want this x to be constant, so that its value can't be changed? So what I have to do is to add this keyword before the declaration or initialization of x. So now if we try to build the program, we're going to get an error, and this error says that x is a read-only variable, which means that its value can't be changed, and we're trying to assign something to it. So now x is a constant. And by the way, if I didn't initialize this, let me comment this line of code, and now let me run the program. As you can see, x contains garbage, and this garbage is constant, we can't change it. So what's the point of making a constant if we don't want to initialize it? So always when you want to make a constant, initialize it to the value that you want. So for example, this x is a constant that is equal to 5. Now I know that x has the value that I want, not some garbage, and this value is constant. Okay, these are declared constants. As you can see, we are using the normal declaration or initialization, and we're adding the const keyword. Now we're going to have a look at defined constants. So what I want you to do is to come over here, add a number sign, and type define. Then hit space, and now write the name of the constant. Let's say I want to make a constant called pi. And now put a space, and now we put the value of this constant. So let's say it is 3.14. So now I have a constant called pi and has a value 3.14, and I can use it like any other variable. So for example, I can say y is equal to pi. Now let's run the program, and as you can see, y is now equal to 3.14. One more thing I want to mention in this video is the address of a variable. So this is a variable in the memory, and also y is a variable in the memory. And each variable has an address, its unique address. So in order to find this address, we have to use the AND before the variable name. So for example, I'm printing AND y. Let me build and run this. And as you can see, I get this number. This is actually the address of the variable y in the memory, and it is printed as an integer. Addresses are in hexadecimal. So I'm going to show you the address of y in hexadecimal. So build and run. And here is the address of y in hexadecimal. If you don't know what is hexadecimal, just Google hexadecimal and have a look. So we have this variable x, which is equal to 3, and this double y, which is equal to 3.5. Let's say we want to print the values of x and y. Then we are going to use a function which is called printf. So what's a function? It is a group of code. And someone made this function that prints something. So in between these parentheses, we have to tell printf what we want to print. And printf takes strings, so it takes something between double quotes. So if I want to print hello, I can say printf hello. Now build and run, and as you can see, we see this printed. So I'm giving printf a string to print. I can't give it something like this, it will give me an error, as you can see. Now we know that printf takes a string. Let's say we want to print the value of x. We can't just say printf x like this, because x in this case is a string, and if we build and run this, we're going to see x. So whenever we want to print a value, we have to use what's called format specifiers. So for example, let's suppose I want to print x equals. So this prints x equals perfectly. Now I want to print the value of x. So I have to use the format specifier for an integer, because x is an integer. There are many format specifiers for each type, but one of the format specifiers of an integer is %d. So we put this %d between the double quotes. So now printf knows that I want to print x equals, then I want to print a value of a variable of type integer. So now I want to tell printf which variable I want to print. So in order to do so, after the double quotes, we put a comma, and now we specify the name of the variable we want to print. So in this case, I want to print x. Now let me build and run this, and as you can see, x equals space was printed perfectly as it is, and then this %d was replaced by the value of x, which is 3. So this is it. Printf knows that this %d is for this variable x, and it prints its value. Now let's suppose we want to print the value of y. So I'm going to use printf and I will print y equals, and now I want to use the format specifier of a double, and one of the format specifiers of a double is %lf. So now I want to tell printf which double I want to print. So in this case I want to print y. So let me build and run this, and as you can see x is equal to 3 and y is equal to 3.5. Perfect. I want to say one thing, they are printed on the same line. So in order to get to a new line, we add this \n. This is a special character that gets me to a new line. So let's build and run this now, and as you can see we printed x equals 3, so we printed everything up until the \n. Then the \n got me to a new line, and now we are executing this printf, so we printed y equals 3.5 on a new line perfectly. Okay, so now I want to show you how to print multiple variables in the same printf. So I want to print the value of x, and I want to get to a new line, and right here I will say that I want to print the value of y. So I want to print y equals, and now I will use the format specifier for the double, which is %lf, and now I want to tell printf that I want to print y. So after x I put a comma, then I put y. So printf knows that the first format specifier is the first variable and the second one is for the second variable. So let me build and run this, and we get the same output as before. So we printed this, then we got to a new line, then we printed this. Now let me show you this. Let's put y over here and let's put x over here. So we're saying that the %d is the format specifier of y and %lf is the format specifier of x. Let me now build and run this, and as you can see the values were not printed. So we have to be specific on which format specifiers we are using. We cannot use the format specifiers of an integer to print a double, and also we cannot use the format specifier of a double to print an integer, and so on. So now we have these more variables and I want to print them. So let's start. I want to get to a new line and I want to print this f. So I will say f equals, and now I have to use the format specifier for a float, which is %f. And now I will get to a new line and I want to print this character c. So I will say c equals, and I will use %c as a format specifier, and that's it. Now I want to print a boolean. So as we know, a boolean has two values, 0 or 1. So we can use the format specifier of an integer to print a boolean. So let's say b equals %d. And now we want to print this string, so I will get to a new line and I will say name equals, and I will use %s as a format specifier for a string, and that's it. Now I have to tell printf which variables I want to print. So the first one is x, the second one is y, and the one after that is my float f, then my character c, then my boolean b, then my variable name. Now let's build and run this. And as you can see, x equals 3, y equals 3.5, f 5.6, c, a, b 1 because it's true, and name is printed perfectly. Now we know that this prints 6 digits automatically. So I want to show you something. Let's say that y is equal to 3.589, and I want to print y rounded up until 2 decimal points. So over here I will type 0.2. Now let's build and run this. I press F9 in order to build and run without pressing on this button over here. So as you can see, y equals 3.59. So this number was rounded and we get 3.59. If I want to round up until 1 decimal point, so I use 0.1, so build and run, and we get 3.6 as you can see. Okay, so one more example. Let's say printf, your name is, I want to print the string, so I say name, build and run, and it is over here, hello, your name is Ali Badran. And if I want to get to a new line, I put \n over here, build and run, and here we go. So this is it for printf. I will remove this example over here, and now let's talk about scanf. Let's say we want to take input from the user. So for example, let's make a double age and initialize it to 0, and now we want to ask the user for his age, so printf enter your age, And now we want to take this information from the user. So we have to use the function scanf. This function also takes a string in double quotes, but for example we can't write enter your age. This gives us an error. We have to use printf in order to make an output, and scanf is only used to take input. So over here I have to tell scanf what I want to read or take input. So I want to take a double, so I use the format specifier of a double, which is %lf. And now I have to specify in which variable I want to store this information, so I want to store it inside age. But this here gives me an error. Scanf takes the format specifiers and the address of the variable I want to store the information in. So over here we have to give it and age, and now this is correct. So now let's do this. For example, your age is, and we want to print a double, so %lf, and this double is age. So let's build and run this. So enter your age, let's say 20.5, and now we press enter, and as you can see your age is 20.5. So now we're starting to take input from the user and printing it. So this is very good. So now I want to show you something. Let's say I have int x equals 0 and double y equals 0. And now I want to take x and y from the user. So I can say I want to read an integer, and also I want to read a double, and I want to store the integer in the address of x, and I want to store the double in the address of y. And after this I want to print x equals %d and y equals %lf, and I want to print x and y. Perfect. Let's build and run this. So now it's waiting for me to enter x and y. We can do this in two ways. We can enter x, for example 4, and press enter, and now y, for example 4.5, and press enter. As you can see, x is equal to 4 and y is equal to 4.5. Perfect. The other way is to enter them on the same line separated by a space. So for example 3 and 8.9. So press enter, and as you can see x equals 3, y equal 8.9. So now I want to show you something interesting. And a very important note, and it's obvious, since we are reading %d first, we have to enter an integer first, and then we enter the double. The order is important. So let's say we try to enter 4.5 inside x. You might think that 4.5 will be casted to 4, and then this 4 will be put inside x. Let's press enter and see what will happen. As you can see, x is equal to 4 and y is equal to 0.5. So why is that? Let's imagine that we will move along this number and we will store what we can inside x. So first of all, we are at 4. So 4 is an integer, so we can store 4 inside x, and we store it. Now we reach this point. So point cannot be stored inside x because x is an integer. So this 0.5 remains with us. Now we are going to read a double. So we have this 0.5, so we don't ask the user to give us input. So this 0.5 is actually 0.5. So as you can see, 0.5 was stored inside y, and the program did not wait for us to enter y. So let me build and run this again. And for example, let me type 4.5 and 2.3. Let's press enter, and as you can see, 4 is inside x and 0.5 is inside y, and 2.3 was ignored. And the program doesn't wait for me to enter y. So this is a good thing to know. So I want to show you another thing. I'm reading x and y in separate scanfs. Let me build and run this, and let's enter 4.5, and we still have the same problem. So as I said before, the 0.5 was still with us. So now I'm going to get rid of this 0.5. So I'm going to use a function called fflush, and I'm going to give it standard input. So the 0.5 was still in the standard input. So I'm flushing this standard input. So I'm getting rid of the 0.5. So let me build and run this, and now let me type 4.5 and press enter. And as you can see, the program is still waiting for me to enter y, because there is nothing with us. We got rid of the 0.5. So now I can enter 2.3 and press enter, and as you can see, x is equal to 4 and y is equal to 2.3 perfectly. What happened? 4 is stored inside x and 0.5 was still with us. Then we got rid of it, and then we store 2.3 inside y. Perfect. So now I'm going to make a character C and I will put it equal to 0. So 0 will be casted to a character and put inside C. I think that 0 in the ASCII table is null. Null means that it is nothing, okay? So now let me comment this flush, so Ctrl+Shift+C, and let me read this character. So %C, and I want to store it inside the variable C. Now over here, I'm going to print C, so %C, and over here C. And Y will stay the same. So let's build and run this. I'm asked to enter a character, so let's say A, and now I press enter, and now let's enter 4.5 and press enter, and as you can see everything went correctly. Let me put the cursor on this line, press Alt and press the up arrow, so I'm going to move this line of code. So now I'm reading Y, then I'm reading this character. Let me build and run this. So 4.5, press enter, and as you can see it didn't wait for me to enter C. And over here we printed C, and as you can see we got to a new line. So what happened? When we typed 4.5 we pressed enter. So this enter was inside stdin. So just as before, because we have it, the program didn't wait for us in order to fill C, and it stored this new line inside C. And you can see it over here, we got to a new line. So in order to fix this, all you have to do is to flush stdin after we read Y. So now let's build and run this, and now let me enter 4.5, and as you can see it waits for me to enter C. So let's say A, press enter, and here you go, C is equal to A and Y is equal to 4.5. So there is one other way in order to fix this problem. Let me comment this line of code, and before this %C just add a space. Now if we build and run the program, let's enter 4.5 and A, and everything works correctly. Just a note before we move on. Suppose we are reading two variables in this scanf, and one of these variables is a character. So there must be a space over here. Just like in this case, we put a space to fix the problem. Here is the same thing. But suppose that we are reading an integer, this space can be removed and we have no problem. But in the case of %C, we must put this space. Okay. So one more thing. For those who are interested on how to make a string and read it, continue watching this video. So I'm going to make a variable called name, and it is a group of characters, and I'm going to say that it has maximum 50 characters. Now when I want to read it, I'm going to use %s, and now I'm going to say where I want to store this string. Okay, so what you're thinking of is that we put the address of name, but actually this is not correct, and you don't have to understand this right now. Just take the idea. This name is the address. This is not a normal variable. This is different from C and Y and X. So put this in your mind. This name is the address. So in order to fill this string, we have to give the address, which is in this case name. Okay, let me remove this and let me print name %s, and I will print name. So let me build and run this, and let's say this is my string CSA. Now I press enter, and as you can see CSA was stored in name perfectly. One more example. If you try to enter more than one word, so it is separated by a space, so let's press enter, you will see that you get only the first word. We're going to talk about this later. So this is it for this video. It's a lot of information and I hope that you get a lot from it. Okay, so in this video we're going to talk about arrays. You can think of an array as a group of variables or elements that have the same type. So for example, if I want to make 10 variables of type integer, then I can make an array that has 10 elements of type integer. Before we continue, I want to mention one thing. If I declare a variable x, we said that the integer takes 4 bytes in the memory. So whenever we declare a variable of type integer, we allocate 4 bytes in the memory for this variable. And now these 4 bytes are ready to be used. And whenever we want to use a space in the memory, we have to allocate it. Okay? So keep this in mind. It is called allocation. So first of all, we're going to talk about one-dimensional arrays. So right here, as if I'm making a variable, we have integer. Then we type the name of the array. In this case it is nums, a short for numbers, and then we open these brackets. Whenever we open the brackets, we specify that this is an array. And since we are declaring this array, we are not initializing it, we have to specify the number of elements. So I'm saying that I want 10 elements. So now I have an array of 10 elements, each one of type integer. So to access each element, we have to use the index of the element. In an array, the index starts from 0. So the index of the first element is 0. The second element is 1. Up until the last element, so in this case, the index of the last element is 9. So let's access some elements. We type the name of the array followed by brackets, and inside we put the index of the element. So in this case, I'm accessing the first element and I'm assigning it to be equal to 5. The fourth element is equal to 2, and the last element is equal to 3. And over here I'm printing these elements, and I'm also printing the second element, the fifth element, and the eighth element. Let me build and run this program, and as you can see we have 5, 2, 3 perfectly, and we have this garbage in these elements over here. So in order to initialize this array, we can initialize all the elements to be equal to 0 by putting equal empty braces. Right now all the elements will be initialized to be equal to 0, and of course these statements are going to be executed. So let me build and run this program, and we still have 5, 2, 3, and the other elements are zeros, as you can see. So let's suppose I want to initialize the first 3 elements. So for example, the first element is 5, the next one is 6, and the next one is 3. So this way we initialize the first 3 elements, and the rest of the elements is going to be equal to 0. So let me comment this line of code, and now let's build and run our program. And as you can see, the first element is equal to 5, the fourth element is 0, and the last element is 0, and the second element over here is equal to 6 because we initialized it. And of course we can initialize all the elements. So for example, like this, I initialized all the elements of the array. Let me build and run this, and as you can see we obtain our result. And by the way, this is not garbage anymore, okay? But I didn't modify this printf. Okay, so right now because we are initializing our array, we can remove this 10 from between the brackets. The compiler will count these numbers and it will automatically guess the number of elements. So if I build and run this program, the program will work perfectly and the compiler will guess that the size of this array is equal to 10. Okay, so as I said, the index of the last element is equal to 9. Let's look at this example over here. I'm saying nums and the index is 10 is equal to 9. And then I'm printing this element. Let me build and run this. And as you can see, we get the output 9. And we also see return 0. So we don't observe a clear error. But actually, the element nums sub 10 does not exist. And the memory for this element is not allocated. So we are using a space in the memory without allocation, and this is very bad. In the best cases, the program would crash or stop working, but as you can see, in my case, the program works perfectly. So always be careful about not exceeding the bounds. Okay, so now we're going to look at two-dimensional arrays. They look like a table or a matrix. So in order to increase the dimensions of an array, all we have to do is to add more brackets. So in this case, we are talking about two-dimensional arrays, so we're going to put 2 brackets, as you can see. So the first bracket will contain the number of rows, and the second one will contain the number of columns. So right here, we're declaring an array called nums table that has 2 rows and 3 columns, and we're initializing all the elements to be equal to 0. So over here, we're accessing the first row and the first column. So this is the first element, and we're setting it to be equal to 1. And over here we're accessing the second row and the second column, and we're setting this element to be equal to 2. Then I'm printing these 2 elements, and I'm also printing the element at the second row and the third column. So let's build and run this, and as you can see we have 1, 2 and 0, and this 0 is because we initialized this array. Okay, so let's see now how we can initialize this two-dimensional array. I'm going to comment this line of code and remove this comment over here. So we have the same array and we're going to initialize it. So first of all, we open braces. Now imagine that the first row in this array is a one-dimensional array. So in order to initialize it, we're going to use braces and we're going to enter the numbers. And since we have two rows, then we're going to open this brace and also this brace. And since we have three columns, then in each braces we're going to have three elements. So here I'm initializing the first row and here I'm initializing the second row. So let me comment this line of code and let me build and run this program. And as you can see, when we printed these elements, we got 1, 5 and 6. This over here is the first element in the first row. This over here is the second element in the second row, so it is 5. And this over here is the third element in the second row, so it is 6. One more thing to talk about, and it is addresses. So let's suppose we want the address of this array. We can get it in two ways. We can say that we want the address of the first element in the array, and also we can get it using the name of the array itself. So here I'm printing the name of the array and the address of the first element as integers because I'm using %d. So let me build and run this, and as you can see, we get the same result. And this is why when we had a string or character array called name and we wanted to use it with scanf, we gave scanf the name of the array and we said that the name is actually the address. And now we are seeing that in action. So now let's suppose that we have a two-dimensional array and we want the address of the first row in this array. So we can get it in three ways. The first one is taking the address of the name of the array and we just supply the index of the row that we want. So for example, if I want the first row, so I get the address of nums table sub 0. If I want the second row, then I take the address of nums table sub 1. Also, we can take the address of the first element of the row. So if I want the first row, I can take the address of nums table sub 0 sub 0. So this is the first element in the first row. And if I want the second row, I can get the address of nums table sub 1 sub 0. So this is the first element in the second row. And if I want to get the address of any other element, for example, I can get the address of nums table sub 1 sub 1 normally. Also, the name of the array gives me the address of the first row of this array. And as you can see here, we have the same result, and also here, and here we have the address of this element. So now you have all the information you need in order to work with arrays, and I want to say some other things. So arrays have fixed size. So if we declare an array having 100 elements, it's impossible to increase the number of elements of this array. We have to redeclare it with the new size. So for example, let me run the program. Imagine that the program is still running. There is no way that I can increase the number of elements in the array while the program is running. I have to come over here and, for example, change the number of columns to be 4. And then I need to build a new program and run it. Okay, you can put as much dimensions as you want, but some compilers have a maximum number of dimensions, but it's hard that we reach that maximum. The most type of arrays you're going to use is the one-dimensional array and the two-dimensional array. So for example, this array has 3 dimensions. As you can see, we have this pair of brackets and this one and this one. So now we will talk about C strings, but before we do that, I will show you an example of a character array. As you can see, I have this array of characters. It is called ARR, and I initialized it to these characters A, B, star, and over here I'm printing these characters, as you can see. So let me build and run this, and you can see these characters normally. So we can make a character array just like an array of integers, and right now we will see how we can make a string using a character array. So for example, over here I have an array called first name, and as you can see, I'm initializing this array to be equal to a string, which is in double quotes. So if we want to look at this array in the memory, we will see that this array is made up of 4 characters, A, L, I, and \0. So this \0 is called the null terminator, and every string in C must end with a \0. So actually, if we want to put a size for this array, we have to put 4, not 3. And over here, I'm not putting a size because I'm initializing. So the compiler will automatically guess the size of this array. And also, the same for this one, I'm initializing it to this string. And if we look at the memory, we will see these characters. And the size is 7. And also, we can remove these braces and we will get the same result. So a very important note here, we can use the equal operator or the assignment operator only when we are initializing. And you will see what I mean in a little bit. For now, let me build and run this program. And let's see this array over here. I'm making an array of characters that has 5 elements. And then I'm printing this array as a string. So as you can see, we have this garbage inside this array. So in order to get rid of this garbage, we can initialize this array. So for example, this array over here, it is a string and I'm initializing it to empty braces so that all the elements are going to be equal to \0. Then I'm printing this string as a string, as you can see, and we have nothing over here, so there is no garbage. And then to show you that all the elements are equal to \0, I'm printing this. So as you can see, %d, 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 and I'm using this equal to see if this element is equal to \0, and also this one, and also this, and also this. And as you can see, we have 1, 1, 1, 1, which we know is true, 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 true. We are going to talk about this equal later on, but I just wanted to show you this. So whenever you initialize a string, all the elements will be equal to \0s. And this string over here, we don't know where is the \0, and we don't know if it ends with a \0 or not. So always initialize your strings. Okay, so let me build and run this program. And right here, I'm printing the string called first name. This one over here. So you can see this string printed perfectly. Then I'm using a function called strlen, and I'm giving it the name of the string or the address of the string, because we know that the name of an array is the address. So this function returns the number of characters in this string. And I'm saying it returns just like when we saw process returned 0 and we said that the main gives us a number or an integer. So also this function gives us an integer, which is the number of characters. So you can consider that this function is just like an integer variable. So we can print it. And as you can see, I'm using %d, and I get that this string is 3 characters. And this is correct. Then I'm using this sizeOf operator, and I'm also giving it the name of the string, and as you can see, we have 4. So this 4 is the number of bytes that were allocated for this string. So one character in the memory takes 1 byte. And since here we have 4 characters, A, L, I, and \0, 4 bytes were automatically allocated for this string. And as you can see, strlen counts the number of characters without the \0 because we got 3. Okay, so I'm doing the same for this string over here, and as you can see, we can see the string, and there is 6 characters in the string, and 7 characters were allocated because we have \0. So now I'm making another string. I called it first name copy, and it has 4 characters, and I initialized it to \0s. So if I want to say that first name copy is equal to first name, I will get an error. We cannot use the assignment operator with the strings. As I said, we can only use it whenever we initialize a string. So in order to make an assignment of strings, we have to use a function called strcopy. So this strcopy function takes 2 strings to work with. The first one is the destination string, and the second one is the string that we want to copy. So this function over here, you can imagine that we are saying first name copy is equal to first name. So the value of first name will be copied to first name copy. And then I'm printing first name copy, and as you can see, we see this string and it is the same as the first name. And by the way, the strlen function and the strcopy function are found inside the string.h header file. So we have to include this file in order to use these functions. And also I'm going to use functions related to characters, and we have to include ctype.h in order to use these functions. Okay, so remember, you cannot use the assignment operator with C strings. So right now I'm going to make a string, and I'm going to combine the first name and the last name in this string. So I'm making a string called full name, and the size of full name is the length of first name added to the length of last name plus 1 for \0. So now I'm going to copy first name and put it inside full name using the strcopy function. So now full name contains this string. And now I want to add the last name to full name. So I'm going to use a function called strcat, and cat is short for concatenate. So this function adds a string to another one. So over here we are giving the full name, and then we are giving the string that we want to add to full name. So we are adding last name to full name. So now full name contains this string followed by this string over here. And then I printed full name, and as you can see we have this string over here. And you should remember that you must allocate the correct size for this string. So I'm printing the length of the string, and as you can see we have 9, and then I'm printing how many bytes we have allocated for this string, and we can see 10. So now we're going to see a function called strcmp or strcompare. In order to compare strings we have to use this function. So this function also returns an integer. So I'm printing this function as an integer. So let's say I want to compare first name and first name copy. So I say strcompare first name, then first name copy. And as you can see we have 0 over here. So whenever we compare two equal strings, the strcompare returns 0. And over here I'm comparing last name with first name, and as you can see strcompare returns 1. So whenever the two strings are not equal, we will get something different than 0. Now look over here. I'm comparing the string A with the string B, and we get -1. And this is because A is less than B alphabetically, because A comes before B. And over here I'm comparing banana with apple, and as you can see we have 1. And this is because banana is greater than apple alphabetically. In order to compare these two strings, we compare them character by character. So we start from the first one, so B is compared to A, and B is greater than A. So this string is greater than this one, so we get 1. So strcompare returns 3 numbers. 0 if the strings are equal, -1 if the first string, for example this one, is less than the second string, for example this one. And it returns 1 if the first string is greater than the second string. Perfect. So let me close this program. I'm going to comment this line of code, and I will remove this comment over here. Now I'm going to build and run this program again, and over here I made a string that has 20 characters, and I initialized it to \0s, and then I'm using scanf in order to read this string. And now we know why we give scanf the name of the array, because it's actually the address. So enter your full name, and now I'm going to press enter. Over here I'm printing the string str, also the str length, and also the size. So as you can see, we only took the first word of this string, so we stopped at the space, and the str length gave me 3, and the size of gave me 20, because when we made the string we put 20 over here. So right now I will show you how to take a string with the spaces. So I'm going to comment this line of code, and I will remove the comment over here, and let's build and run this. I'm using a function called gets, which takes the name of the string. This function reads a string with the spaces. So let's enter, and now I will press enter, and as you can see, when I printed the string I got the whole string. Also strlen gave me 10, and the size of operator is still 20. So whenever you want to read a string with spaces, so it is made of many words, you can use gets function. Also, if you want to print a string, you can use a function called puts, which takes the name of the string, and this will print your string without using printf. So let me comment this printf, and I will build and run this program, and I will enter this string, then I press enter, and as you can see, the string was printed. Perfect. So now we're going to look at some character functions. So all these functions we're going to talk about returns 0 if the thing we are testing is false and everything else is true. So for example, if we want to see if a character is a letter, then we use a function called isAlpha, and I'm printing it as an integer, and as you can see, I'm giving it the character h. So I'm testing if h is a letter, and as you can see, I got 2. 2 is different than 0, so isAlpha is true, then h is a letter. Over here, I'm testing if the character 1 is a letter, and as you can see, we get 0 because 1 is not a letter. We have another function which tests if a character is a digit. A digit is a number between 0 and 9. So I'm printing isDigit, and I'm giving the character 1, and as you can see, we have 1. So this is true, so 1 is a digit. And I'm testing if h is a digit, and as you can see, we get 0, so h is not a digit. Over here, I'm testing if 1 is a character or a letter. So as you can see, we get 4, so this is true because 1 is a digit. And over here, I'm testing if h is a digit or a letter, and we get 2, so this is true, and this is because h is a letter. And we are using the function isAlNum. And now we're going to see this function which tests if a given character is a lowercase character. So for example, isLowerH gives me 2. So this character is in lowercase, and as you can see, this is true. And isUpperH gives me 1, so this is also true, and as you can see, h is in uppercase. So now I'm printing h is %c in lowercase, and I'm printing this function, toLowerH. This function takes a character and it converts it to a lowercase character, and I'm printing the result of this function as a character. And as you can see, we get h is lowercase h perfectly. And we have a function called toUpper which converts from a lowercase character to an uppercase character. And we have this function isSpace which tests if a given character is a space. So this character is a space, and as you can see, we get 8, so this is true. There are more functions in the C type. If you are interested, Google C type header file and check it out. So in summary, these functions return 0 if the test is false and return other than 0 if it is true. I will show you a little example of using these functions. So what I'm doing over here, I'm going through every character in the string CSA. You don't have to understand anything, just take the idea. Then I'm testing if each character is a lowercase character. Then if it is a lowercase character, I'm saying that this character is equal to toUpper this character. So I'm assigning the lowercase character to be an uppercase character. And then I'm printing this string, and as you can see, all the smaller case characters were converted to uppercase characters. So as I said, you don't have to understand anything, just take the idea. And over here we have a little summary of some things that we talked about in this video. Okay, so let's talk about operators. First of all, we already know what's the assignment operator. So for example, we have these two variables a and b, and then I'm saying a is equal to b. So the value of b will be put inside a. Then I'm printing a and b, and as we already know, we have a is equal to 2 and b is equal to 2. Now let's take a look at the arithmetic operators. This is the addition operator, subtraction, multiplication, division, and the modulo operator. The modulo operator gives me the remainder of the division. So now we're going to see some examples. We have this variable x is equal to 2 and y is equal to 3. Then we can add x and y and store the result inside a variable called sum, as you can see. Right now I'm printing sum as an integer, and as you can see, we have 5. Now over here I'm printing also an integer which is equal to x minus y, so we get -1. Then the multiplication is giving me 6, and the remainder of the division of x by y is equal to 2. And also the remainder of the division of y divided by x is equal to 1. So for example, on using the remainder, if we have a variable x and we want to know if x is an even or an odd number, then we can get the remainder of the division of x by 2. If the remainder of the division is 0, then x is going to be even. And if it is not 0, then x is going to be odd. Now we're going to take a look at the division operator. So for example, I have 5 divided by 2 and I'm using the %lf. So I'm printing 5 over 2 as a double. And as you can see, we have 0.000. The value of 5 over 2 was not actually printed. Let me explain. 5 is an integer and 2 is also an integer. So this division is going to give us an integer value. So we are trying to print an integer using the %lf. And that's why we don't see the answer. Over here I'm using the %d as you can see, and I'm printing 5 over 2. And as you can see, we have 2. And the 0.5 was lost. Now let's take a look over here. I'm dividing 5.0 by 2. So 5.0 is a double and 2 is an integer. So this division will automatically convert 2 to be a double, and then we will get an answer which is a double. So I'm printing this as a double as you can see, and we get the answer 2.5. Perfect. So let's now do this using x and y. So I'm printing x divided by y as an integer, and as you can see we get 0. The correct answer is 0.6, and we lost the 0.6 because this is an integer. So over here I'm printing this as a double, and I'm casting x to be a double. Just like over here when I transformed this 5 to be 5.0. I'm doing the same for x, so I'm converting it to be a double, so that y is also going to be converted to a double, and this division will give me a double answer. And if you look over here, we got our answer. This over here is casting x to a double. We also can cast y to a double and we will get the same result. So for example, I will remove this and I will put it before y. So now I'm casting y to be a double. Let me build and run this, and as you can see we also get the same result. And it is obvious, in order to make a cast, we put two parentheses, and inside them we put the type that we want to convert to. So in this case it is a double. Perfect. So now let's see the compound assignment operator. For example, if we say a plus equal to, this is the same as a equal a plus 2. So we take the operator and we apply it on the left side and on the right side, and the answer is stored in the variable on the left side. So as you can see, we are calculating a plus 2 and the answer is put inside a. One more example, if we say a times equal 2 plus b, then we have to calculate a times 2 plus b, so you can imagine this between parentheses, and the answer will be put inside a. So this is it actually, and this can be applied on all other operators, not only the addition and the multiplication. So as you can see, I'm printing a over here and over here, so let me build and run this. Firstly, a was equal to 2, then after this statement, a was equal to 4. And after that, after this one, a is equal to 16, because 2 plus b is equal to 4, and as you can see over here, we are multiplying a by 4. So 4 times 4 is equal to 16, then 16 is stored inside a, and that's why we see 16 over here. Now we're having a look at the increment and decrement. Increment is plus plus and decrement is minus minus. Everything will be clear in a little bit. So we have this integer I initialized to be equal to 0. I'm printing the value of I, so as you can see we have 0. Then I'm saying I is equal to I plus 1. So we will take the value of I, which is 0, and we will add it to 1. So this is equal to 1, and we will store 1 inside I. And then I'm printing I, and as you can see we have 1. So this over here is an increment. This is equivalent to I equal I plus 1. So basically we are adding 1 to I. So I was equal to 1. So after this statement I will be equal to 2. And I'm printing I, and as you can see we have 2. This is called post increment because the plus plus comes after the name of the variable. Over here we have plus plus I, and this will do the exact thing as I plus plus. And this is called pre-increment because the plus plus comes before the name of the variable. So I will be equal to 3, and I'm printing it, and as you can see we have 3. So when you are using I plus plus and plus plus I alone in a statement, they are the same. So we basically add 1 to the variable. But now we will take a look at what happens when we use them inside other things. So for example, I'm saying printf and I'm printing an integer which is I++. What will happen here exactly is that we will take the current value of I, which is 3, and we will print it. Then we will increment I so that I will be equal to 4. This is, as I said, post increment. So as you can see, we see 3 over here. So we took the current value of I and we printed it. And over here I'm printing I in order to see that it was incremented, and as you can see we have 4 over here. Now I'm using printf ++i. This will increment I and then we will print the new value. So I was equal to 4, we will increment it, so I will be equal to 5, then we will print it. So as you can see, we see 5 over here. So whenever we have I++, we will use the current value of I, then we will do the increment. And whenever we have ++i, we will do the increment first, then we will use the new value of I. So one more example, I'm making integer h is equal to I++. So what will happen over here, we will take the value of I and we will put it inside h, then we will increment I. So the value of I right now is 5, then as you can see h is equal to 5. And I is equal to 6 because we incremented I. And now I'm making an integer k is equal to ++i, so we will increment I and the value will be put inside k. So I was equal to 6, so it will be equal to 7, and then 7 will be put inside k. And as you can see, k is equal to 7 and I is equal to 7. So the same goes for the decrement, but instead of adding 1, we subtract 1. Perfect. Now we will have a look at the relational operators. Equal equal tests for equality. Exclamation mark equal tests if two things are not equal. This is the greater than sign, less than sign, greater than or equal, less than or equal. So let's see these examples over here. I'm printing 1 equals 1 as an integer. First of all, since we are comparing, the value is going to be true or false. So this is a Boolean value and we can store it inside a Boolean variable or inside an integer. Because we know that the values of a Boolean variable are an integer 0 or 1. So as you can see, I'm printing 1 equal 1 as an integer. So 1 equal 1 is true. 1 is not equal to 1 is false, because 1 is equal to 1. 1 is greater than 1 is false. 1 is greater than or equal to 1, this is true, because one of these was satisfied and it is 1 is equal to 1. 2 is greater than or equal to 1 is true, because 2 is greater than 1. So whenever we use greater than or equal, I'm saying or equal. So one of these should be satisfied, not both. Over here, 1 is less than 1, this is false. And 1 is less than or equal to 1, this is true, because 1 is equal to 1. Perfect. So as you can see, we have one condition over here. If we want to join more than one condition, we have to use what's called logical operators. So we have the logical AND and the logical OR. To use the AND operator, we put two AND signs together. And to use the OR operator, we put these two together, and you normally find them above the shift button on the right side of the keyboard. So if we join two conditions and we use the AND operator, the whole solution will be true if and only if both conditions are true, and it will be false otherwise. Regarding the OR operator, the whole solution is going to be true if at least one of the conditions is true, and it will be false if and only if both conditions are false. So now we will see some examples. I'm also printing these values as integers, and now we're going to have a look. So 1 equals 1 and 2 equals 2 is true, because this condition is true and also this condition is true. So the whole condition is going to be true. Now we have 1 is equal 1 and 2 is not equal to 2. This is true, but this is false. So the whole answer is going to be false. And as you can see, it's false. Now we have 1 is not equal to 1 and 2 is not equal to 2. So the whole answer is going to be also false, as you can see. So AND is only true when all the conditions are true. Now let's have a look at the OR. So 1 equals 1 or 2 equals 2 is true because there is a true condition. Over here we have 1 equals 1 or 2 is not equal to 2. This is true and this is false, but the whole answer is true because we have one condition that is true. Over here we have 1 is not equal to 1, which is false, or 2 is not equal to 2, which is also false. So the whole answer is going to be false, as you can see. So using the OR operator, we will get false if and only if all the conditions are false. And we can join as many conditions as we want. So for example, this is the first time that we see this. So this is basically making two or more variables of the same type. We put the type over here, then the name of the variable, and if we want, we can initialize it. Then we put a comma and we make more variables of the same type. So O and P have the same type integer, and initializing O to be equal to 1 and P to be equal to 1. So now look at this condition. 1 equal 2 and 1 different than 2, or O equal P and O equal 1. So we are joining all these conditions together, and as you can see over here we have true. So what happened exactly? What's inside parentheses will be evaluated at first. So 1 equals 2 is false, so this AND is false. So now we have false or something. So if this thing is false, then the whole answer is going to be false. And if this thing is true, then the whole answer will be true. So O equal P is true because O is 1 and P is 1. And O is equal to 1, this is also true. So all this is going to be true. So the whole answer is going to be true, and as you can see, we see true. Also, we can remove the parentheses. Let's build and run this, and we get the same result. But in order to be sure how we want these values to be evaluated, always use parentheses. What's inside parentheses gets evaluated first. Okay, now we're going to take a look at the size of operator, which we have already seen. So this operator is used to see how many bytes are allocated for a variable or a data type inside the memory, and it returns an integer. So we can print it as an integer variable. So I'm using %d, and I'm printing size of the variable O, and I'm also printing size of O between parentheses. So whenever we have a variable, we can put parentheses and we can remove them. It gives us the same result. And O is an integer, so as you can see, we have 4 bytes for an integer. And we can also use size of with data types. So for example, size of int, size of double, size of char. But when we want to use data types, we have to put them inside parentheses. So the integer takes 4 bytes, the double 8, and the character takes 1 byte. One more thing to mention is operator precedence. So for example, if we have this over here, O plus P minus O times 3 plus 4 divided by 2, this will be solved exactly like we solve mathematics in school. So multiplication and division first, then addition and subtraction. So you can imagine this written as O plus P minus between parentheses O times 3 plus between parentheses 4 divided by 2. So we will get 1 plus 1 minus 3 plus 2, which is equal to 1. So a better way in order to make sure that you get the answer you want is to put everything inside parentheses. So you don't have to memorize which operator works first. You can always use parentheses, and what's between parentheses will be always solved first. So if we build and run this, we will get the same result as you can see. I will put a link in the resources so that you have a look at the precedence of operators. You don't have to memorize them, but just have a look. And as I said, you can always use parentheses in order to make sure that you get what you want. So one more thing I want to say, we still have the exclamation mark operator. This is the not operator. It basically negates the Boolean answer. So for example, not true is false and not false is true. So for example, let's put an exclamation mark around this expression. And by the way, an expression is something that can be calculated, just like this one. So if I build and run this now, you will see that we have 0 over here. So we had 1, and now we have the negation of 1, which is 0. And also the negation of 0 is equal to 1. So now we will see how we can take decisions in our program. So as you can see, I have this integer x and I'm taking it from the user. So now I want to say if x is equal to 1, I will print that x equals 1. So this is an if statement. As you can see, we type if and we open parentheses, and inside the parentheses we put our condition. And then the first statement that we write after the if statement will be inside the if statement. So if the condition is true, this statement will be executed. And if the condition is not true, this statement will not be executed. So I'll build and run this program and I will enter 1. As you can see, x equal 1 was printed. Now let's try another example. I will enter 2 and as you can see, this statement was not executed, as if this code over here does not exist. Perfect. So now let's say that we want to do something if the condition is not true. So we have to use the else keyword, and the first statement after the else will belong to the else. So let's printf x is not equal to 1. So now let me build and run this, and I will enter 2, and as you can see, the statement inside the if was not executed, and the statement inside the else was executed. So we see x different than 1. Let me build and run this again. I will give 1, and as you can see, the statement inside the else was not executed. So up until now we have one statement inside the else and one statement inside the if. If we want to put more than one statement, all we have to do is to add some braces. So right now everything inside these braces belong to the if statement. So I added this statement, and over here I'm going to add this statement. Perfect. Let me build and run this, and I will enter 1. So as you can see, this statement was executed, and also this one, because the condition is true, and the statement inside the else was not executed. But this statement over here was executed, because this statement is not inside the if, and also it's not inside the else. So let me add some braces, and I will put this statement inside the else. So let me build and run this. Let me enter 1, and as you can see, both of these statements were not executed. Let's see another example. I will enter 2, and as you can see, both of these was executed. Perfect. Let's say that inside this if, we have another if. So let's say if x is less than 10, and over here I'm going to change the condition if x is greater than 5. So if x is greater than 5, I'm testing if x is less than 10, so I will print x is greater than 5 and x is less than 10. And then I will put an else over here, and I will print x is greater than 5 and x is greater than or equal to 10. Because if x was not less than 10, then it is greater than or equal to 10. So this else statement belongs to this if statement. Always the else belongs to the first if above it, and this else statement belongs to this if over here, and we can remove these braces. So as I said, the first statement after the if statement belongs to it. So we have this if over here, and this statement over here is the first one after this if. So this if belongs to this one, and after that we have this statement inside this if statement, and this else over here belongs to this one, and we have this statement inside this else. So we do not need braces. Perfect. So let's try this. I'm going to build and run this, and first of all I'm going to make this condition false. So I will give a number that is less than 5, for example 3, and as you can see, these statements inside this else were executed. Okay, now I will give a number greater than 5 and less than 10, for example 6. So as you can see, this condition was true, also this one is true, so this statement was executed. Let's look at another example. So I will give a number that is greater than or equal to 10, for example 10, and as you can see, this is true, but this is not true. So this statement inside this else was executed. Perfect. So one more thing, we have this if inside this if. So we can join these two conditions using the AND operator. So AND x less than 10. And now if I remove this if, and also I will remove this else over here, and let's build and run this. So we give 6, and as you can see, we get the same result, and I will give 10, and we get also the same result. Perfect. So let's imagine if the condition is not true, I want to test for another condition. So inside the else, I will say if x equals 10, printf x equals 10. And if not, printf x is greater than 10. Perfect. Let's remove this condition and just keep x less than 10. So if x is less than 10, we will print that x is less than 10. If not, we will test if x equals 10 and we will print it. And if not, we will say that x is greater than 10. So you might be saying, why not just put it like this? If we put it like this, it will give us the same result. But if this condition is true or if it is false, we will come and check this condition. But if we have an else over here, if this condition is true, we will save time and we will not come over here. Perfect. So let's build and run this. Let's say 5, x is less than 10. Let's say 10, x equals 10. And let's say 11, x greater than 10. Perfect. So now have a look at this code. As you can see, I'm testing if x equals 11, if x equals 12, and if x equals 13. When we are testing for equality, we can do this using a switch statement. So let's do this. First of all, we start by typing switch, and then we open parentheses, and inside we put the variable that we want to test. In this case, it is x. Then we open braces and we put a semicolon, and inside these braces we'll start putting our conditions. So for example, I have x equals 11. So I have to type case 11 colon. So in here I will put what I want to do if x is equal to 11. So I will just print that x equals 11. Now I have case 12 and I will print that x equals 12. And also I have case 13 and I will print that x is equal to 13. Perfect. And by the way, if we want to make this a lot better, we have to add else statements over here. So as I said, we will be saving some time. So now let me remove this code. And now we will build and run this program and we're going to test it. So let's first of all enter 11. So as you can see, x is equal to 11. So we entered case 11 and we printed this and also this and this. Let's try it again. Let's put 12. Now x is equal to 12. So we entered this case and we printed this and this. So as you can see, whenever we enter a case, we are executing it and everything below it. So if I want to execute this case and not execute what's below it, I have to add a keyword called break. So this keyword takes me out of the switch statement whenever I reach it. So if we enter the case 11, we will execute this statement and we will get out of the switch. So I'm going to add a break over here and also over here. And I will add one more thing, which is default, which will be executed if none of these cases was satisfied. So let's printf none of the above. Perfect. So this default statement, normally we put it at the end. So there is no need for a break statement after it. So let's build and run this program. Let's put 11, and as you can see, only x equal 11 was printed. 12, the same. 13, also the same. And now let's enter something different than all these cases. For example, 15. And as you can see, this statement inside the default was executed. Perfect. We have two doubles and one character, and we are taking input from the user, the two doubles and the character. And over here we are making a switch for the character. So this is basically a calculator. If the character is plus, then we will print the addition. If it is minus, the subtraction, division and multiplication. And if the user enters anything other than this, we are going to display invalid operator. So let's build and run this. Okay, so let's try 1 plus 2. And as you can see, we see 3. Another example, 3 times 7, we get 21. Now let's enter an invalid operator, 1E4. E is not a valid operator, so let's press enter. And as you can see, invalid operator. Perfect. So one more thing to talk about, and it is the ternary operator. So let's suppose I have two integers, x equals 4 and y equals 3. Let's say that I want to get the maximum between x and y. So I can say that if x is greater than y, I will say that max is equal to x. I'm going to initialize a variable called max to be equal to 0. And if not, this means that y is greater than or equal to x. So we can say that the maximum is equal to y. So this over here can be written in another way using the ternary operator. So let's comment this code, and over here open parentheses. Then put the condition. So I'm going to put x greater than y. So this is a condition. So I'm going to add a question mark. And right here I'm going to say what I want to assign to max if the condition is true. So as you can see, I'm assigning x. Now I put a colon, and over here we put what we want to do if the condition is false. So as you can see, we are assigning y to max, so I'm going to put y. Perfect. So let's now print max. So build and run. As you can see, we see 4, which is the maximum. Change y to be equal to 5. Build and run. We see 5. So what's happening? 4 greater than 5 is false. So y will be put inside max. Let me put this equal 6. So 6 greater than 5 is true. So x will be put inside max. And we got our answer. Perfect. Let's see some more examples. I will remove this ternary operator. And I also will remove max. And I'll put the ternary operator over here. So I want to print an integer. This integer will be x if this condition is true. And it will be y if this condition is false. So let's build and run this. We printed 6 because 6 is greater. Let me put here 7. And as you can see, we have 7 because this condition is false. Perfect. Also, we can give strings. So let's say if x greater than y, I want to print x greater than y. And if not, I want to print y greater than or equal to x. So let's build and run this. So we have y greater than or equal to x. Perfect. Let's change this. Build and run. And as you can see, x greater than y. So let's suppose that we have this array over here. And we want to print the elements of this array. So what we're going to do is to use printf. And we want to print integers. And then we will print nums sub 0, sub 1, sub 2, up until sub 9. So as you can see, we are repeating this code, and the only thing that is changing is the index. So this code can be written much cleaner using a loop. So a loop basically is a way to repeat executing a piece of code. So now we're going to print the element of this array using loops. First of all, we will use the while loop. So I'm making an integer I, initializing it to 0, and this I will represent the index. So we know that I starts from 0 because the index of the first element is 0, and I should end at 9 because the index of the last element over here is 9. So now we will start writing our loop. We're using the while loop, so we write while and we open parentheses just like an if statement. And inside we have our condition. So as we know, I should work up until 9. So we can say that this loop will work as long as I is less than 10, and if we increment I at each iteration, then this loop will work from I equals 0 till I equal 9. And it is the same if we put I less than or equal to 9. So I'll be using I less than 10. So now inside this loop, I'm going to put one statement so we don't have to open braces, and this is my statement. So I'm saying printf an integer, and this integer is nums sub I plus plus. So as we know, this is a post increment, so we will take the current value of I, then we will print nums sub the current value of I, and then we will increment I. So first of all, I is equal to 0. So 0 less than 10, this is true, so we will execute this statement. So we will print nums sub 0, and then we will increment I, so that I is equal to 1. So this loop executed once. Each time the loop execute is called an iteration. So now we are going to the second iteration with I equals 1. So we have to check for the condition. 1 is less than 10, this is true, so we will print nums sub 1, and then we will increment I. Now I equal 2. Then we go to the next iteration. 2 less than 10, this is true, and we will print nums sub 2, and we will increment I. So this will continue, and now let's suppose that we have I equals 9. So 9 less than 10, this is true, so we will print nums sub 9, which is the last element, then we will increment I. Now I equals 10. So we go to check for the condition. 10 less than 10 is false, so we get out of the loop with all the elements printed. Let me build and run this. And as you can see, all the elements were printed successfully. So this is the while loop, and now we're going to print the element of this array using a for loop. I'm going to comment this code, and over here we have the for loop. So first of all, we type for and we open parentheses. In here, the for loop consists of 3 parts. The first part is the assignment or initialization part. The second one is the condition, and the third one is the expression that you want. For example, increment, decrement, whatever you want. And as you can see, between each part we have a semicolon. So at the first part, let's say that we want to make a new variable in order to use inside this for loop. So we can initialize a variable in here. So I'm saying int j equals 0. So this variable can be used inside this for loop, but we cannot use it outside the for loop, and we will talk about this later. Then here comes the condition. So I put j is less than 10. Same as before, we had I is less than 10. Perfect. Then we are incrementing j, because we know that we have to move from j equals 0 till j equals 9. And by the way, plus j or j++ doesn't make a difference over here, okay? Perfect. So also I have only one statement inside this for loop, so I will not open braces, and here is our statement. The same as before, we are printing the elements of this array nums sub j. So let's build and run this program, and as you can see, the elements were printed successfully. So let's see how this for loop works exactly. First of all, this part is executed only once in the first iteration. Then we will check for the condition. So first of all, j is equal to 0. So 0 less than 10, this is true, so we print nums sub 0. Then we go and do this expression. In this case, we are incrementing j. So j is equal to 1. Then we go check for the condition. So 1 less than 10, true, execute the statement, increment, check for the condition, execute, increment, check for the condition, and so on. So let's suppose j is equal to 9. So 9 is less than 10, this is true, so we print nums sub 9, which is the last element. Then we increment j. So j is equal to 10. 10 less than 10, this is false, so we will get out of the for loop. So we can remove this part over here, and we can use this variable over here. So let's say I want to use this variable I. So we can say for I equals 0, just assignment. So we have to put here I, and I. So let's build and run this, and we get the same result. Also, this part can be removed. So we are using this variable, we have a condition, and we are incrementing this variable. Build and run, and we get the same result. And also we can remove this part. So now this for loop acts just like a while loop. So let's build and run this, and we have an infinite loop, just like when we had the while loop. So let's, for example, put here I++, build and run, and we get our result. Perfect. So I'm going to comment this line of code, and now we're going to have a look at a sample program. So let's suppose that I want to take a number from the user between 1 and 100. So first of all, I'm going to take the first input from the user. If this number is between 1 and 100, then okay. But if it is not, I want to keep asking the user to enter a number. So I'm going to use a while loop, and the condition is if the number that the user entered is less than 1, or if it is greater than 100, then it does not satisfy my condition. So in this case, I will ask the user to re-enter the number, and I will take the number from the user. And whenever the user enters a number between 1 and 100, this condition will become false, and we will get out of the loop, and then I'm printing the number. So let's build and run this. So enter a number, let's say 0. So 0 is not between 1 and 100, so as you can see, I'm asked to re-enter the number. Let's enter 1000. So the same thing. Now let's enter 50. So this is a number between 1 and 100. Press enter. And as you can see, this condition is now false, because 50 is greater than 1 and 50 is less than 100. So both of these conditions are false. So all this condition is false. And as you can see, this statement was executed successfully and we see perfect 50. Okay, so as we saw, we have to take the first input from the user in order to decide what we want to do. So we took the input outside of the loop. We can rewrite this program in another way using a do-while loop. Here it is. So a do-while loop, we type do and then we open braces, and inside of here I'm telling the user to enter a number between 1 and 100 and I'm reading this number. So what will happen is that I will take the input from the user and then I will test for the condition. So if the condition is false, I will get out of the loop, and if it is true, I will re-execute this code. Then I will check, execute, check, execute, check, execute until the condition becomes false. So the do-while loop executes the code at least once and then it works just like a while loop. But a while loop checks the condition at first. This is why we have to take the input outside of the loop. Perfect. So let's build and run this. So I commented the variable over here, so I remove the comment, build and run again. So as you can see, we have this statement over here printed. So I'm going to comment it out, then build and run, and here we go. So enter a number between 1 and 100. I'm going to enter the exact same thing. So 0, I'll have to re-enter the number 1000, and now I will enter 50, and everything works perfectly. We got out of the loop, and this statement was executed successfully. Perfect. So now we'll have a look at the continue and the break keywords. We saw break using the switch statement and it got us out from the switch statement. So with loops, the break does the same thing. It gets us out from the loop. We mostly use it with infinite loops that we want to get out from on a certain condition. Regarding the continue keyword, when it is executed, we are basically going to the next iteration. So let's see this example. We have this integer initialized to be equal to 0 and you are telling the user to enter a number less than 5. Then we have this while loop and it is an infinite loop. This one, when converted to a boolean, it is true because it is different than 0. So this condition will remain true forever. So this loop is an infinite loop. So in order to get out of this loop, we will need a break statement inside it. So we want a number that is less than 5. So first of all, I'm reading a number from the user. So if the number is not less than 5, this means that the number is greater than or equal to 5. Then inside this if statement, I'm telling the user to re-enter the number and I'm saying continue. So whenever we reach continue, everything below it will not be executed and we will automatically go up here and reread the number from the user. So now we are sure that whenever the user does not enter a number that is less than 5, we will keep asking him to enter a number. Perfect. Now let's suppose that the user enters a number that is less than 5. So this condition is false, so this if statement will not be executed. So this code over here will be executed. So I'm printing the number for the user and I'm using break to get out of the loop. Let me build and run this. Enter a number less than 5, let's say 6. So I have to re-enter the number 7, 8, 9 as you can see. Now I will enter a number that is less than 5, so let's say 3, and as you can see, this statement over here was executed and we got out of the loop and the program ran successfully. So let's suppose that we don't have this break statement. Build and run. Let's enter 7, 6, 8, and now let's enter a number that is less than 5, let's say 3, and as you can see, this statement was executed and we got up here and the program is now reading a number from me, as you can see. So let's enter 3, 3, 3, 6, 7. And as you can see, we are stuck inside the loop. Perfect. Now we'll have a look at another example. I'm using the continue keyword inside a for loop. So this example, in order to show you that the continue keyword takes me to the k++ in this example. As we know, the next iteration in the for loop takes us to this expression, then we go and check the condition, then we execute the code. So let's see what we have here. I'm using a variable k equals 0 up until 9 and I'm incrementing it. In here, I'm saying if the remainder of the division of k by 2 is equal to 0, I want to continue. So if k is an even number, I want to continue. So I will go to the k++, then check for the condition and then re-execute the code. And this statement over here will not be executed whenever we execute the continue. So basically, I'm not printing the even numbers. And if I have an odd number, this continue will not be executed, and this statement over here will be executed, and then we will go make k++, check for the condition, and re-execute. So let's build and run this, and as you can see, we have the odd numbers printed. So first of all, k is equal to 0. 0 is an even number, so we make continue. K++, now we have 1, is not an even number, so we go to this printf. The continue is not executed, so we print 1. Now we go to k++, we have 2, 2 is an even number, so we continue. K++, we have 3, 3 is not an even number, so we print 3, as you can see. This continues the same. Let's say that we have k is equal to 9. So 9 is less than 10, this is true. 9 is not an even number, so we print 9. Now we make k++, so k is equal to 10. 10 less than 10, this is false, so we get out of the loop, as you can see. Perfect. The last thing I want to show you is the calculator that we made previously. So what I did, I put the calculator inside a do-while loop. So this calculator will work as long as the operator is different than q. So whenever we enter the operator q, the program will finish. So let me build and run this. 1 plus 2, for example, 3 times 7, 9 divided by 2. As you can see, we are using the calculator many times. And when I want to exit, I'm going to give the program q. So let's put any number, then q, then also any number, and if we press enter, we will get this invalid operator because we have this default over here, and now this condition is false because the operator is now equal to q. So we got out of the loop and the program executed successfully, as you can see. So before we talk about functions, I want to talk about scope. So for example, look at this variable over here. This variable is declared inside the body of the main function. So the scope of this variable is the body of the main function. This means that we can use this variable in between the braces of the main function. Now look over here, we are using this variable in this for loop. So we are using this variable in the scope of the for loop. So the scope of the for loop can access the scope of the main. Let me build and run this, and as you can see, we have our output perfectly. And also after the loop, I try to print I and it prints 10. Perfect. So a smaller scope can access a bigger scope. Let's have a look at another example. We have this loop over here. We are initializing this variable to work in the for loop. As I said before, this variable can only be used inside the for loop. So the scope of this variable is the for loop, and I cannot use it outside the for loop. So if we try to print j over here, we will get an error. Let me build this, and here is the error. So whenever this for finishes working, this variable is destroyed, as if it never existed. Okay, so as you can see, a bigger scope cannot access a smaller scope. Perfect. Now we will see another example. We have this variable declared inside the scope of the main, and it's initialized to be equal to 100. And then I'm opening braces. You might find it a little bit weird, but this is possible. Basically, I'm making a new scope inside the scope of the main. So I'm printing a variable called num, then I'm making another variable, initializing it to be equal to 3, and it has the same name as this variable. And also I'm printing the variable num. So let's first build and run this, and you will notice that we have no errors even if we have two variables having the same name. And if we look at the output, we have 100, so this num is the one over here, and here we have 3, so this num is the one over here. So what's happening exactly? First of all, when we create a new scope, let's imagine that we are creating a new home for variables. So we can make variables having the same name as variables in another scope. So this num over here is in the scope of the main function, and this num over here is in the scope of these braces, and they are completely independent. So I'm printing here a variable called num. So what I have to do is to search within this scope over here for a variable called num that is declared above this statement. As we know, we cannot use variables before we declare them. So as you can see, there is no variable called num declared above this statement. So now we go out of this scope and search in the bigger scope. In this case, the bigger scope is the scope of the main. So if we search over here for a variable called num, we find it over here. So that's why we printed 100. After that, we declared this variable inside this scope. And now we try to print a variable called num. So as before, we try to search for a variable called num inside this scope, and we actually find one above this statement, which is this one. So this is why we see 3. So the rule is always search from the smaller scope, and if you don't find a variable that is declared and you can use, then you go to the bigger scope. Perfect. So this is it about scopes. Why I talked about them? In a little bit we will start making some functions. As you can see, for example, I have a variable called I over here. This I is inside the scope of the main. So I can make another function and make a variable inside it called I, and that I and this one are completely independent. Perfect. So I'm going to remove this code over here, and now we will talk about the return statement. You may already know what the return statement does, but now we will have direct applications on it. So I want to make a function that gets the age of the user and gives it to me. Okay? So the age can be a double. So in order to get a double from this function, the type of this function should also be a double. So just like a variable, I will type double. Now I will type the name of this function. So I will call it getAge. And now I will put parentheses and then I will open some braces. Perfect. Now we have our function. And over here we will write some code just like we write inside the main. So I want to get age, which is a double. So I'm going to make a variable called age, initialize it to 0, then scanf a double and store it inside age. Perfect. So now I have this age stored inside this variable. So in order to get this value that is stored inside the variable and be able to use it, I must send it to the main function and work with it over there. So in order to do that, we just type return age. So now whenever I want this function, I will call it and it will get the age and it will return it, just like strlen that returns the size of the array. Okay? So let's use this function in the main function. First of all, since this function returns a value, then I can store the value that it returns inside a variable. And since it returns a double, I'm going to store the value inside a double. And as you can see, this variable is called age. And also this one is called age. But these two are completely independent. The scope of this one is the main and the scope of this one is this function. Perfect. So I'm setting this variable equal to the function getAge. So what will happen? This function will be called and then this code will be executed. So I will get the age. Then the function will return the value that is stored inside this variable. So the value that the function returns will be stored inside this variable. Perfect. After that, I'm just printing this variable over here. Let's build and run this program. So what happened? We know that the main is the starting point of the execution of any C program. So what happened is that we came to the main function, then we executed this line of code. So in here we are calling this function. So we stop executing the main function and we go up to this function. So over here we are taking a value and storing it inside this variable, and as you can see I will enter 20.5 and now I will press enter. When I pressed enter, the value was stored inside this variable and then we returned 20.5. So I want to say something over here. Whenever we use the return keyword inside the function, we will automatically get out of the function. So even if we have some code over here, this code will not be executed. So we return the 20.5, so we get back to the main function, and over here as if we have now 20.5. So this 20.5 will be stored in this variable, and then we printed it as a double, as you can see, and we have 20.5. Perfect. So we made a function that gives us or return something for us. So now I will remove this code and also I will remove this function. And now I want you to make a function called getSum and its type is integer, and I want you to get the answer of 2 plus 3 from this function and put it inside a variable called sum. Then print this variable. So now pause the video and give it a try. So we will start by making the function. So as I told you, we will store it inside a variable called sum and its type is integer. So this function must return an integer. So its type is an int. So now its name is getSum, and it has some braces, and in here we will type our code. So we can say int sum is equal to 2 plus 3, and then we return sum. So 5 will be stored inside sum, then we return 5. So we come over here and 5 will be stored inside this variable, and then we print it and we should see 5. So let's build and run this, and we see 5. Perfect. So let's do it in another way. We do not need this variable. We can directly return 2 plus 3. So now build and run this, and we get the same result. Perfect. So I remove this code, and also we remove this function. And now try to make a function that has the type double, and you should get the answer of 9 over 2 as a double. So I want you to get 4.5. This 4.5 should be stored inside this variable, and then you can print it over here. So give it a try. So we will start making this function. Its type is double because we want to get a double from it. So its name is getDouble. It has some parentheses and braces. So now we will return 9 over 2. But as we already know, this will give us 4 because this is an integer and this is also an integer. So let's for example put 2.0 over here, and now this will give us 4.5. And since the type of the function is double, we will have no problems. So we will get 4.5 over here, and it will be stored in this variable, and we are printing it as a double. So let's build and run this, and we get 4.5. Let's say that the type of this function is int. So let's build and run this. So this division gave us 4.5, but the type of the function is int. So 4.5 will be casted to 4, and then we will have 4 over here, and 4 is stored inside this variable. That's why we see 4. So pay attention that the type of the function and also this division should be compatible with the type double. Perfect. So let's remove this code and let's remove this function. So now imagine that the user wants to give us two numbers. We will store one inside x and another one inside y. But I'm not using scanf over here. I'm just giving you the idea. So I want to make a function that multiplies these two numbers that I do not know and gives me the answer. So this function should take parameters. Just like strlen, it takes the name of the array. This function will take two integers and multiplies them and gives me the answer. So I'm supposing that all the answers are going to be integers. So my function is going to be of type int. The name of the function is multiply, and now I want to give it two integers. So over here we tell the function what we want to give it. So I want to give you an int and also another int. And now we open some braces, and over here we will write our code. But in order to be able to use these two variables, we should give them a name. So let's call the first one x and let's call the second one y. And I say again, this x has the scope of this function, and also this y has the scope of this function. They has no relation with this x or this y. Okay, so in here we will say return x multiplied by y. So whenever we return this value, it will be stored inside this variable and we are printing it. So let's build and run this, and as you can see we have 6 perfectly. So let's go over what's happening exactly. The value of this x is 2. So whenever we call this function, this x over here will be initialized equal to 2. And this y over here will be initialized equal to 3, because this y over here is equal to 3. Then we are returning 2 times 3. Perfect. One more thing I want to say. These here are called parameters because we write them when we are making the function. But these over here are called arguments because they are the values that the function wants to work with. So the arguments are the values that sit in the parameters. It's just a naming thing. It's not so important. Okay, I'm going to remove this code, and also I will remove this function. So the type of the function can be any type that we know: int, float, double, character. And also there is a type called void. Void means nothing, and a function type is void whenever we don't want this function to return anything. So for example, I will make a function called print number that takes an integer x, and this function will simply print this integer. As you can see, I don't need this function to return anything, so it will be useless to make this function of type int or double. So we make it void if we don't want it to return anything. So for example, over here I have an integer z equal to 4, and I'm using this function and I'm giving it the value of z. So 4 over here will be put inside this variable and we are going to print it. And as you can see, this variable name has no relation with this variable name. They can be the same and they can be different. It doesn't matter. So let's build and run this. And as you can see, we see 4. Perfect. So basically, when you don't need the function to return something, make the type void. Perfect. So I remove this function and I will remove this code. So I will make this function has a type void and called byValue, and it takes an integer x and it simply increments x. So over here I'm calling this function and I'm giving it this variable over here, which is equal to 3. So as we know, this variable has no relation with this variable, and over here we are incrementing this variable. So the value of this variable will not be affected. That's why I'm printing the value before and after we call the function. Let me build and run this program and we see 3 and 3. Perfect. And by the way, all the parameters are destroyed whenever we get out of the function. Just like when we get out of the for loop, and for example, if we say for int j equals 0, this j is going to be destroyed. Perfect. Now what if we want to change the value of the variable that we are passing to a function? So we will use what's called pass by reference. So it's basically giving the function the address of the variable. So we have this function called by reference and it should take the address of the variable. So in order to give a function an address, we have to add a star over here. I just want you to get the idea. You don't have to understand everything. And in the main, we have a variable called y, and we are giving the address of y to this function. So right now, in order to modify the value of y, I will put a star, then the name of the variable, which is x, and then plus plus. So here I'm basically saying x contains the address of a variable. I want you to go to this variable and increment it. So as we know, x contains the address of y. So I want to go to y and increment it. So we are going to modify this variable and it will be equal to 4. Let's build and run this and we see 3 and 4. Perfect. So this type over here is called a pointer. And if you are interested, you can Google for it, but for now, you don't have to understand it.